Next up, we have Rob Hurd, who is Business Development Associate for Bechtel, and he's going to be changing subjects a little bit to talk about communication principles for EPC constructability. Rob, welcome. It's the green is the forward, yeah.
Okay. This is going to be fast and furious. I have 3 versions of this presentation, and every time I go over 20 minutes. So let's see, how do I get it going? Okay, so I work for Bechtel. When I tell my friends and family who Bechtel is, I just tell them, think about the world's infrastructure and divide it by 3, and Bechtel probably built it. That's the fastest or easiest way that I can explain who and what Bechtel is about. So this is going to be fast and furious up to section 4, but up in the upper right-hand corner, it kind of gives you a "we are here" in the talk. So like a Quentin Tarantino movie, I'm going to give you the ending of the movie right up front, and then we're going to back our way into it. The first 4 sections are kind of setting the stage for, I think, to appreciate what we're about to get to in section 5 and section 6. So without further ado, I read a Bechtel impact report, and I thought this phrase stood out to me. After 125 years, this is what Bechtel said about itself. Experience has taught us that the quality of our relationships and our one-team mentality are the most important predictors of a project's success. This rang true for me in many ways. I don't have time to unpack why I believe that's the case, but in this talk, what my hope is that I'll talk about communication of know-how and how that improvement in connection improves our relationships and improves that one-team mentality. At least that's the goal. Okay, what is constructability? Constructability is the optimum use of construction knowledge and experience in planning the project and particularly your execution plan. Why invest in constructability? So Construction Industry Institute has publicly said that a good constructability program will yield 4% in project improvement in costs and 7% on schedule. When should you do constructability? As early as possible. So the idea at the beginning of a project is very malleable. So that's where the DNA of the project hasn't really been established yet. That's the time when you can bake in a plan. You can do your value engineering. Is that design manufacturable? Is it constructible? That's the time when you can really bake in that DNA for that project. And so over on the right, something just to quickly highlight is that in construction, there's always this phase of a project where you're going from construction to startup. So you're installing your bulks, you're getting your quantities, you're making progress, but then you got to get into systems mode. And are you getting short-term pains for long-term gains? Is your constructability plan have the overall goal in mind of a successful project, bringing that project in on schedule, on time? So something that Bechtel kind of permeates the culture is this term called certainty of outcome. And it's a strange phenomenon that I've just learned over the years that Bechtel truly believes that everything can be planned and controlled. And it's kind of contagious, actually, because you think, really? And it's just a mindset, and it's hard to explain unless you've been on project execution teams over and over again. Okay, so I'm going to unpack these 5 principles. The whole point of these 5 principles is to just get on the same page so that we can talk about first principle number 5, which is where my heart's at. So first principle 1, EPC projects are irreducibly complex. So you can't just do one, you got to do all 3. It seems like really simple, and it is. But when you have risk rewards between entities that are not aligned, and you have multiple kinds of contractors on a project, all of a sudden, this can get really complicated really fast. So Bechtel, in their self-perform model, it's one of the things that it has proven to improve communication on a project team so that you can holistically optimize the plan and improve communication across teams. First principle number 2 is kind of what we talked about in the last slide. Improving the cost of influence requires getting everybody on the same page. So that blue line right there, you can think of that blue line as the temporary infrastructure plan. That's to build the temporary infrastructure. That's your resource curve. You need the temporary infrastructure to build the permanent infrastructure, which is the red line. And those two plans have to be developed 5 years in advance. That's the green line. So that's what we're trying to do. First principle number 3, Metcalf. So at the end of the day, our builder network is a human network. And we're not fax machines or computers, so there's limitations as to the social interaction that we can have with each other. So this is just something important to note, that in Metcalf talked about telecommunication networks and improving on the square, and what that really means is your connections in a flat architecture grows geometrically. So if you have 10 people, that's 95 or 45 connections. If you have 5 people, that's 5 times 4 over 2, that's 10 connections. So that geometrically grows. And you see that this is a challenge in the field where you have to be more vertically integrated. And when you're working and looking at a job hazard analysis and you're looking at the mitigations for those hazards, you're going to see over and over again, communicate, 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 communicate. And that's a different ask for a 15-person crew versus a 5-person crew. Not to mention if you have SIMOPS where you have multiple crews working in clusters around each other, that's a tough ask. And so trying to unpack how hard that is, it's like saying, hey, just work safe, just be safe, just communicate. And so I think gone are the days where we're just saying collaborate and communicate. We have to unpack what that actually means. And that's what I'm striving to talk about today. First principle 4 is a bit abstract, but I'm going to try to hit on it hard and fast. Networks are space filling. What that means is your project is in a location, your people, your resources, your supply chain, your energy, electricity, utilities for that project will space fill and go to that project. So the infrastructure for your project team, where your high engineering value centers are located, where your supply chains are located, where your strategic fabrication is located, that all matters. That all matters. So number 2, your terminal units builders are invariant. So this is kind of a key one because in the age of technology, we can improve our Internet of Things, our lenses, our VR headsets, and all this compute, spatial compute, all sorts of digital tools. But the fundamental unit of a builder network is a human being. And that human being is unchanging. We have 5 senses, and we have complex neural nets. So that's something to keep in mind. Networks self-optimize, and this is just a fancy word of saying your network will optimize to your plan. So if you have a good plan, it's going to optimize to that. If you have a bad plan, it's going to optimize to that. And so a lot of times in construction, at least in my personal experience, problems are discovered. They're discovered because you just don't know that's an underlying problem until you get to that point in the project. The last principle, first principle number 5, basically what I'm trying to unpack here is there's different modes of thinking and communicating. So I've identified 4: verbal, visual spatial, visual objective, and bodily kinesthetic. And I'm going to briefly go through this slide. This slide is just to indicate that projects are hard. So a mega project, we classify that as any site population over 5,000 people. The disciplines and positions that you see below the E and P and C, those represent teams. So each one of those positions will have teams of people underneath them. And I didn't want to draw a spider web diagram because, that I don't think that was going to do any good. So basically, this slide is just to indicate that your contract conditions, your builder network, your network governance. Sometimes I call that your sandbox rules. So you got 5,000 people out there in a sandbox. How are you going to self-organize? What is that command structure? How do you deal with operational, logistics, right? So that's important, and a network will optimize to the self-governance that it has. Okay. So I'm starting to get into some of the more of the fun stuff. I try to go through that fast. So I'm going to unpack these 4 modalities. First modality is verbal. So verbal is fast, is comprehensive. The weakness of verbal is that it can't describe physical systems with high fidelity. Visual spatial. Visual spatial is an abstract language, so that's a strength of visual spatial. What's weakness? It requires translation. Visual objective, what's its strength? It can describe physical systems with high fidelity. What's its weakness? It requires high skill, typically. Bodily kinesthetic is the 4th modality. This typically will have the highest amount of credibility, but it also comes with the highest cost. So these are the pros and cons of of the 4 modalities. And I'm kind of showing the examples of each modality overlaid over there on the right. Okay, so Adam's a builder. He works for Bechtel Equipment Operations. I met him. They did a Do You Know BEO campaign, and Bechtel's such a big company. As a chief construction engineer for our tanks business line, one of the things that I was constantly doing was designing scaffold. And you might say, why? Why are you designing scaffold? Well, one thing that's unique about tanks is that tanks, you do vertical construction, and they're open top. And so the wind wants to collapse them in. The wind wants to blow them in. So our scaffold solutions require 2 things. 1, they have to provide structural integrity so the tank doesn't blow in during construction. And then 2, they have to provide access for our builders. And I thought to myself, why can't I put that square material in this round hole? And I never even thought that was even possible, because I thought, that's too complicated, that's too complex, that's too expensive. But when I started talking to Adam, he said, actually, no, you can. And we have an MSA, Master Service Agreement, with our supplier. And I think this could be an interesting problem to go ahead and solve. So we activated, what I call activated, the cross-functional matrix at Bechtel. So in this case, I pitched the innovation. We had our idea. I used the verbal modality for that. We visualized our problem. We visualized a solution. We kinesthetically built a mock-up. We did some testing at the Welding Applied Technology Center. We tested the weld. We tested the strength of the materials. And then we piloted at Corpus Christi. Those are 2 firewater tanks. They're 50-foot diameter. And you might say, okay, cool. So why is that, like, what's the impact? Where does this solution apply? And so basically what the solution applies to is that when we're building wind girder scaffolds, we're designing those scaffolds for one-time use, and we're scrapping them because they're designed for that diameter. But with this scaffold solution, we could use it for any tank. So that's a picture of PenChem, and those are chemical storage solutions. And that's Thacker Pass. That's Lithium Americas. That's a lithium plant that we're going to be building. There's a lot of storage requirements for those. We also have low-temp and cryogenic tank storage. What you're looking at, those are the inside of an inner tank and an LNG tank. So some of these low-temp and cryogenic tanks, it's not just LNG. It can be ammonia, it could be ethylene. There's different types of liquid storage that you would apply for those. We could use them for the sphere erection. You're looking at an equator. We're installing the upper hip on an equator. The last bit there is pipe racks. So pipe racks are a big part of what we do. And now going back to, if you can mentally visualize that resource curve, when you're looking at construction costs at, let's say, an LNG facility, number 1 cost is going to be piping, because pipe is king. Number 2 cost is going to be coatings and insulation. And number 3 cost is going to be scaffolding, because you're essentially installing a temporary resources to install the permanent resources. And so with this attachment, which this is the part of the presentation I'm going to go show you what the attachment looks like. Basically, it's really simple. You can have a pre-established lug here on your work surface. And if I can get this pin off here. And this is the scaffold that you can build on the ground. There's different types of system scaffold. This is a ring lock scaffold. So in the productivity studies that BEO has done, they did a lot of productivity gains with ring lock scaffold. And with this scaffold, you can essentially build it on the ground. So you can get your better install rates. You can do it faster. You're doing it on the ground, less exposure. And then you could take that, you could put lifting lugs on it, and then you can see that we've designed it. This is kind of the female connection. This is the interface between the square world and any surface. And this female lands on the pre-established lug. And there's enough gap for construction tolerances. Your permanent material will have construction stack-up tolerances. So in the wind case for tanks, we put the pin in because you can imagine if the tank, it wants to be blown in, this part of the tank is going to come in, and this part of the tank wants to come out like a 4-leaf clover. And so what happens is this lug wants to come in, and this lug wants to come out, and this piece here on the adjacent side will want to ride off. But because you pin it, that keeps the scaffold locked in. And so that's, even though it's as simple as this is, and it's incredibly simple, it makes me think, you've got a builder and another builder sharing their deep domain knowledge. We come up with a very, very simple solution, and it scales across our projects. It scales across all kinds of projects because every project requires tanks. Every project requires racks and other things like this. So that's and also with racks, there's this other things that you could do with this attachment. You could use multi-purpose beams, and you could do all sorts of stuff for flexible dance floors, flexible catwalks, things like this. So BEO is constantly trying to improve the curve and reduce tonnage. And I think I'm out of breath here. I got 5 minutes. I told you it was jam-packed. Jam-packed. Okay, don't worry. We're not going to go through this. The point is I was curious about interfacing with Adam. That box is Adam. That's Keith. That's Philip. That's Vivek. That's EK. That's Brick. That's Jordan. And we had to communicate with each other. We had to communicate across modalities. And people, at least on my teams, asked me, if I wanted to invent something in the company and get it to technical readiness level 9, because we use that NASA scale at Bechtel. Technical readiness level 1 is you have an idea. Technical readiness level 9 is it's installed, it's been piloted on multiple projects, and it's a mature innovation. There's a lot of ways that you can do that, but communicating in the visual and kinesthetic modalities is really important. So one of the lessons learned for me is construction experience is the fuel for the constructability process. Having that bodily kinesthetic experience is the fuel. And not only that, the experience and the visualizations, they accelerate team understanding. So what you're asking your teams to do is complex coordination. So if your teams are doing complex coordination on things that they're struggling to visualize, on things that they're struggling to understand, what's the physical benefit of this? It doesn't lend itself to being able to do optimal analysis and visual spatial analysis. So one of the and so that being the main lessons learned, in 2022, I submitted an idea to corporate innovation, and the idea was we should enhance our ability to collaborate with each other kinesthetically and visually. And I call this solution Mission Builder. And what that allows us to do is find the right know-how for the right person for the right project and get those SMEs talking on their particular project. Early in the project life cycle, where the projects are malleable, but also as projects have issues, you can virtually cluster your SMEs and go work those issues more efficiently if you have this domain, this search of know-how. And that's what this is going to be. So next year, or actually this year, we're going to pilot this software on 2 mega projects in the Gulf Coast, Port Arthur LNG and Rio Grande LNG. So stay tuned on how that goes. Okay, closing thoughts. I didn't think I'd be able to get this. I got 2 minutes left. So these are just kind of disparate data points. One of the things that Craig Albert, he's the COO, of Bechtel, he used this phrase that stuck with me. It's the mental health is the hard hat of the 21st century. And there's a statistic that CDC has out there that construction workers and builders, I call them, they're committing suicide at rates 5 times higher than job incidents. And then my colleague, another chief construction engineer in another GBU, sent this to me the other day. The National Federation of Builders, they put out a neurodiversity report, and they represent a construction body in the UK and Wales. They said 1 in 4 construction workers consider themselves neurodiverse. And, what does this mean? I don't know, right? All I know is if we can improve the connection between builders, one of the things that personally means a lot to me is that if your work is seen and heard, you feel like a part of the team. And it makes me wonder how many construction professionals feel seen and heard on our projects? I don't know. But I think that by improving connection and not having the visual and kinesthetic modalities technologically underserved, I think we'll learn something that maybe we didn't learn before. So, thank you.
Thanks, Rob.
Yeah.
Thanks. And Rob, a very obvious question, but good one to ask. For Bechtel, do you envisage this constructability model going beyond the EPC industry, petrochemical producers?
Beyond the EPC industry, I think this, sharing of deep domain know-how is a human thing, and the applications for solving problems go beyond constructability and construction, and manufacturability. This is going to be super meta answer, so I apologize. But when I think about like the arc of human history, and I think of like going from the open system of the sun, and then now we're in a closed system, and we're trying to go back to the open system and use the closed system sustainably. We're going through this other transition because of the second law of the law of entropy. Everything turns back to dirt. Everything we build will turn back into dirt. And so really, it's just a matter of when. And so we're living in this dirt to dirt cycle. So in my estimation, if we can improve our biological network of connection across company lines, across organizations, the applications of building infrastructure for the globe, it applies. Whether it's machinery for energy generation, or whether it's machinery for chemical manufacturing, or whether it's machinery for recycling, or whatever the technology is that we need to live sustainably on this biosphere that we call Earth, exchanging know-how from neural net to neural net is applicable. So that's my Star Trek, answer, I guess.
Okay, thanks.